Good morning, everybody. Um, we are going to take a look at our last lecture for 7-1, which is naming and writing formulas. And it is about naming acids. So um, we did our ionic compounds, we did our molecular compounds, and now we're going to wrap up with acids. Okay. And with acids, the one thing you should know is that anytime a substance or compound begins with H, it's going to be an acid. So if it begins with hydrogen, it's going to be an acid. And there's two types. And the first type here you can see on your screen is when you have just H with a non-metal. So that would be H with like Cl or F or Br or S or N, anything like that. That's called a binary acid. The other one on the next page of your notes will be H with a polyatomic ion. So H with like nitrate or H with sulfate or something like that. Okay, so we're going to go through those two. And then today you're going to do a little assignment on just naming and writing some formulas for acids. And then tomorrow will be your review. And then on Wednesday will be your test on naming. Okay, so our first type of acid is called a binary acid. It's an acid consisting of just two elements. So it's H and a nonmetal, like I mentioned. It takes the form hydro, and then you put the root of that particular nonmetal here with the ic ending, and then you add the word acid. Okay, so if we take a look at this first example, HCl, it's just H and a nonmetal. So it takes the form hydro. Okay, then the root of chlorine is just chlor. And then we add the ic ending, IC, and then we add the word acid. So HCl is hydrochloric acid. Okay, pretty simple. All right, now here's H2S. We'll go on to this next one. Just H and a nonmetal. The only reason there's two H's is because sulfide is a -1 or -2, excuse me. So you need two H's to balance it out. H is always +1 in an acid. So that's the only reason there's two. That doesn't go into the name at all. So it's just H and a nonmetal, so we name it hydro. And then the root actually for sulfur is sulfur. So we just have sulfur, and then we add the IC ending, so it's sulfuric, and then we add the word acid. Okay, so H2S is hydrosulfuric acid. Okay. Now, when we get down here to going in the opposite direction, going from name to formula, okay, anytime you see the word acid, okay, H plus is going to be your positive ion. Okay, always. So even when we do the oxyacids or the acids with a polyatomic ion, H plus is always going to be your positive ion. Okay, now we look at brome, that's bromine or bromide. Okay, so that's Br -1. Okay, now you have your two ions side by side, H and Br, H plus, Br minus, already equal and opposite, just HBr. So hydrobromic acid, final formula, HBr. Okay, so we're still using that crisscross method. You have +1, -1 to do that. Okay, let's go over here and back this one up one. There we go. So you see the word acid, H plus, always your positive ion. Okay. Now nitric, that goes back to nitride or nitrogen, and that's N -3. Okay. So now you have H plus N -3. So we need 3 of these, 1 of those when we do our crisscross method. Really, one thing to think about with acids, the hydrogen is always, the number of those is always the charge on the negative ion, because it's always a +1. So if the negative ion is a -1, there's 1 hydrogen. If the negative ion is a -2, there's 2 hydrogens. If it was a -3, there's 3 hydrogens, and so on. Okay, so this one here would be H whoops, I got 2 in there, H3N. Okay, H3N would be hydronitric acid. And again, there's 3 H's because N's minus 3. Okay, so those are your binary acids, just H and nonmetal. Uses the prefix hydro. Okay, that's not because it starts with H, that's because it's binary. Because it starts with H, it has the word acid. So don't add hydro to all your acids, only the binary ones. Okay, so let's go down here to our oxy acids. So there's 2 types of oxy acids. And they're when H is with a polyatomic ion that ends with 8, okay, or it ends with ite. Remember, a lot of our polyatomic ions end in 8 or ite. Okay, so the rule is if you have H in a polyatomic ion, if that polyatomic ion ends in 8, you change the 8 to ic, and then you add the word acid. Okay, so let's look at HNO3. So it's an acid. It begins with H. We know that. It's H in a polyatomic ion. Okay, so NO3, that name of that polyatomic ion is nitrate. So we change the 8 to ic and add the word acid. So this is nitric acid. Okay, it's nitric acid. So notice there's no hydro there. Okay, and that's because it's not a binary acid. It's just a regular acid, so we just changed the ending. Okay, now let's look at this one, H2SO4. Only reason there's 2 H's is because SO4 is a minus 2. Okay, so SO4 is sulfate. Okay, so you change the 8 to ic and add the word acid. Actually put the UR back in there for this one. If you wrote sulfic acid, that's not a big deal, but it is sulfuric acid. The root of sulfur is sulfur, so that one's sulfuric acid. Okay, so 8 to ic. Now going in the other direction down here, see the word acid. Okay, H plus is your positive ion. Okay, and now we go in reverse. So ic goes back to 8 to know which polyatomic ion this is going to be with. So carbonate, or from carbonic, okay, is CO3 minus 2. Okay, so there's carbonate, CO3 minus 2. Okay, it goes back to 8. So now we just have to crisscross our charges and have our correct formula. Okay, so minus 2 there, there's 2 H's and 1 CO3. So H2CO3. Okay, H2CO3 is your final answer. And remember, again, this is the same as the binary. The charge on the polyatomic ion is going to be the number of hydrogens that you have. So you have H2CO3. So you have 2 hydrogens because CO3 is a minus 2. Okay, acetic acid over here. See the word acid, H plus. Okay. Now acetate or acetic goes back to acetate. Now acetate's that one where if you look at, here's our common polyatomics. It's right here. All right, and you can write it in 2 ways. You don't have to write it both ways, but you can write it in 2 ways: C2H3O2 minus 1 or CH3COO minus 1. Okay, so either way you want to write that, that's up to you. So I'm going to do CH3COO, and that's a minus 1. Okay, so now we have plus 1 minus 1, already equal and opposite. It says right, it says it's going to be H, CH3COO. Oops, capital is there. There we go. Okay, or you could write it HC2H3O2, same thing. Okay, you can write it either way. All right, so these ones you do the same, it's just a different ending. Okay, so if the polyatomic ion ends in ite, like many do, chlorite, nitrite, sulfite, phosphite, change the ite to us, O-U-S, and add the word acid. So down here, if we take a look, it begins with H, so it's an acid for HClO2. Now ClO2, that's chlorite, so you change your ite to us, so it is chlorous acid. Chlorous acid, okay, for that one. No hydro. Hydro is only when it's H in a nonmetal, okay? Let's move over here. Here's H2SO3, begins with H, so it's an acid. SO3, sulfite. sulfites. So this is sulfurous. Remember that UR goes back there. So that same thing happens with phosphorus. Okay, sulfurous acid for that one. H2SO3. All right, and going from name to formula, you see the word acid, H plus is your positive ion. Now phosphorus, that goes back to phosphite. Us goes back to ite. So phosphite, that is PO3 minus 3. Okay. So you have H plus PO3 minus 3. Crisscross your charges. You're going to need 3 H's. So H3 PO3. H3PO3. So the 3 goes there, H there, H3PO3. Okay. And lastly, nitrous. Nitrous acid. Us goes back to ite, nitrite. But we see the word acid, so H plus is our positive ion. Now, nitrite, NO2 minus 1. So plus 1 minus 1, okay, already equal and opposite. Just write it, HNO2. Okay, so that brings us to the end of our acids and naming those. Remember, there's 2 types. There's H in a nonmetal, H in a polyatomic ion, and they're named differently. Okay, so try the homework. If you have any questions, let me know.